Alright, so we just left off creating hazards in our game. So if we run the game now, we can go jump on the red spike and respawn over here. The next step is going to be to create checkpoints so we don't always have to reload the whole level when we hit the hazard. One thing I noticed just playtesting is that if I land on this crate, I can no longer jump. And that's because we need to tag our crate as ground. So if we were to click on our crate here, well, there's a couple ways we could deal with this. We could either just put it on the ground layer, or we could make a new layer for stuff like this, like interactive objects, and then on our player character, where we have our ground layer mask, we would need to make sure we check whatever that interactive object layer that we created was, so that that counted as ground also. Um, for now, just to keep things quick and simple, I'm going to just move the crate onto the ground layer, and I think I should be able to jump off of it now. Yeah. Alright, anyway, that has nothing to do with checkpoints, but it was just bugging me. So what I'll do, let's just move the crate even just out of the way. We'll put it up there for now. And I will have to start by making a new visual representation of my soon-to-be checkpoint. So let's go into our sprites folder here, and let's make a new sprite, just so everything is easy to tell apart from one another. So you right-click in the project window, go to the Create, find Sprites, and let's just make the checkpoint a diamond, which more or less is just a rotated square, but it's easy to get in there different so it looks distinct from our player. And I'm going to go ahead and change its color also, so that it's just another visual difference from the player. So I'll make it like purple, something like that. And so that'll work. I'm going to also have to add a box collider to this so that we can detect when the player touches it. So I'm going to go ahead and click on Add Component and start typing in Box Collider. And I'm going to find Box Collider 2D here, and I'll select that. And this one, remember on the spike, we wanted to make sure the collider, the hitbox, like mapped very closely to the spike visual, because we don't want the player to feel cheated if he touched this part of the area and then died and it didn't look like he was actually touching the spike. Well, for the checkpoint, it's actually going to work the opposite. I want to give the player all the chances they can get to accidentally hit this checkpoint. It's good to hit the checkpoint. So I'm happy with my box collider encompassing these areas that aren't actually visually represented by my diamond sprite. So I don't feel the need to actually closely map the diamond visual to the diamond hitbox in this case. Alright, anyway, while I'm at it, let's go ahead and rename it from diamond to checkpoint before we forget. And I don't want the player to be able to land on top of the checkpoint. Like if I were to run the game now, I can stand on this thing. That's not what I really want. The player should pass through the checkpoint. So that means it needs to be a trigger. So with your checkpoint game object selected, go into the box collider section in the inspector and make sure you check is trigger. And that way we can still use that hitbox to detect when the player intersects with the hitbox, but it should no longer block me. I can pass through it now, and that's what I want. Alright. At this point, I think we need to go ahead and enter our scripts folder, and we're going to have to make a script for our checkpoint. So I'll right click in the project window, go to the create menu, and choose new C# script. And I'll just name this one checkpoint. Alright, so now I'm going to double click my checkpoint script and it should open in Visual Studio. Okay, so the first step to this is going to be to just simply detect when the player has touched the checkpoint. So I'm just going to start by deleting the start and update stuff that gets automatically created when you make a new C# script. I'm going to move the open curly bracket down onto a new line just because that's the style I prefer. And I'm going to insert an onTriggerEnter2D function. So if you just start typing onTriggerEnter2D, IntelliSense should pick it up and you should be able to click it or hit enter to autocomplete that function for you. And you remember this will work pretty similarly to how our hazard worked, right? We need to detect if it's actually the player that's touching our checkpoint. So I can just actually go ahead and copy, I'll just copy this whole if statement here. So line 10 through 14 from hazard. And I'm going to go back into checkpoint and paste that in. Now, what this is doing, just to refresh your memory, collision is a reference to whatever touched the trigger. So we're going to say if the game object that touched the trigger has the tag player, then we want to do something special. Actually, I'm noticing this game object, I can actually get rid of that and it works just exactly the same way. So if you want that to be shorter, you can delete game object there. Anyhow, we don't want to load a new scene when the player touches a checkpoint, so I'll delete that line. And I guess before we really even do anything, let's just change this debug.log to say something about the player entering the checkpoint, and just double check that we're correctly detecting when the player enters the checkpoint and printing this message. So I'm going to save my scenes, or I mean save my scripts rather. I'm going to go back to the Unity editor and play the game, and when I touch that purple thing, that purple checkpoint, I would like to see my print statement, although I just realized it's not going to work because I forgot to put the script, the checkpoint script, onto the checkpoint game object. So you'll see when I have the checkpoint game object selected here, there's no script on it. So don't forget to drag your script onto your checkpoint game object. I'm going to move it down to the bottom in theory. Maybe not, I don't know. And yeah, I guess this is as low as it can go. Alright, anyway. So here's my checkpoint script. Now if I run the game, since it's actually on the checkpoint game object, I should see that print in the console when I touch it. So I'll walk into it and it says the player entered the checkpoint. Okay, so that's good. Now we need to figure out what do we actually want that to do. So let's go back to Visual Studio and let's take a look at our player character script. I think, at least initially for now, we will have the easiest time if we keep track of the current checkpoint in the player character script. So up here at the top of the script, after my serialize fields, in this little section where where I have created just plain old private fields, I'm going to make one more private field, and I'm going to call it private, and it's going to be of the type checkpoint, and I'm going to call it current checkpoint. So basically I'm making a variable in my player character class of the type checkpoint, and it's going to keep track of the current checkpoint. So the player will know what its current checkpoint is. So now our new problem that we have to solve is how do we if we're detecting when the player hits a checkpoint in our checkpoint script, how do we somehow change the value of this current checkpoint variable inside of the player character script from the checkpoint script? And there's a lot of different ways to do this. The way I'm going to show you today is by creating a new function that we will call from checkpoint. So player character will have a function called and we'll call it set current checkpoint. So I'll just kind of scroll down to the bottom of my player character script here, and I will make a function private void set current checkpoint. Okay, and we'll need to have an open close curly bracket, and what we want this checkpoint, or what we want this function to do, is update the value of that current checkpoint variable we created. So we're going to say current checkpoint equals something, right? Well, what should it equal? In order to figure that out, I think we need whoever's calling this function to pass in a little bit more information. And so that's how we can use parameters inside of these inside of these parentheses here. So what I'll do is type the type of data that I want first. So I need to know what the new current checkpoint is going to be. So that's going to be of the type checkpoint. And then I need a name for this data that we're passing in when we call this function. So I'm just going to call it new current checkpoint. And it's best to make sure you name this parameter in a way that clarifies what kind of information you're supposed to pass into this function when you call it. So whenever I call set current checkpoint, it's pretty clear that I need to pass in a object of the type checkpoint, and it needs to be the particular checkpoint that I want to count as the new current checkpoint. So again, this is just an example of how we can name things in a way to make it clear what they are for, what they do. So anyhow, inside of the function here, we're going to take our current checkpoint variable and we're going to set it equal to whatever we pass in as the new current checkpoint. So we'll just say equals new current checkpoint. And that's it. So this would be great if when we are in our checkpoint script here, we could somehow get a reference to the player character script and call set current checkpoint. So how are we going to do that? Step one is get a reference to this player character. The way to do that, so we know if we reach this print statement, we know that we are that the player is in fact the thing that has touched our checkpoint, because that's what this compare tag condition is doing for us. But so that means that if we were going to look at our player character game object here, we know that it's this game object because this has the tag player and nothing else does. Well, what we need is within this game object, we need to have access to this player character script. So the way that you can get access to a component on a game object is with the getComponent function. So what I'll do is I'll go ahead and make a variable of the type player character. So I'll say player character player, and I'm going to set that equal to collision, which is our thing that hit the checkpoint, dot getComponent player character. And the getComponent function has a special syntax where you have to provide an angle bracket here and inside of the angle brackets is the type of the component that you want. So in this case, we want to find a player character component and store that inside of this variable we just made called player that's of the type player character. Alright, so just to reiterate, what this line of code is doing is when we call getComponent here, it's going to search this game object that touched the checkpoint trigger for a component of the type player character. And there's only one of them, it's this. And so that's what the getComponent function will find, and we will store that into the player variable here. So now I can do stuff with the player object by typing this variable and hitting period, and I can have access to all the stuff that my player character can do. Well, this brings us to an issue. I know that my player character has a set current checkpoint function. So in theory, I should be able to type player and hit period and find set current checkpoint in the list on IntelliSense of functions that it has. But it's not showing up. And that's because it's marked private. Now, typically we want to make everything private unless there's a good reason to expose it with public. And in this case, I need other outside classes to be able to call this function. So I'm going to have to expose it to outside classes by changing it to public. So as a rule, we're going to try to avoid making public variables as much as possible. But in the case that we do need another outside class to interact with this class, we can accomplish that by making a public function. And there's more ways to do this, but for now this is the pattern that we're going to follow. Alright, so I have changed my setCurrentCheckpoint function to public. And now, if I go back to the checkpoint script, I'll just backspace over, and then right after the R in player, I'll hit period again. And then I'll start typing setCurrentCheckpoint, and there you can see it's showing up in IntelliSense. So I'm going to hit open parenthesis to autocomplete that line, because I knew that was going to be the next character I needed to type anyhow, so it's just a little faster that way. And now I can see or remember, because of the IntelliSense help message here, it's telling me that I need to pass in an object of the type checkpoint that will be used as the new current checkpoint after I call this function. So the answer to what checkpoint I should pass into that is just this checkpoint. This is the object that the player bumped into, so this is what I want to use as the new current checkpoint. And because this is all happening inside of a checkpoint script, I can just type in this, and you'll see if you select it, if I click this, you'll see it's referring to checkpoint. So it's actually referring to this particular instance of the checkpoint. And so that's what I want to pass into the player when I call setCurrentCheckpoint. So what's happening is the player is going to bump into the trigger. We're going to check and see if it's the player that actually hit it by comparing its tag. If it has the player tag, we're going to go ahead and assume that this is in fact the player that has touched my checkpoint. And then we'll go inside of this if statement and we'll say, well, since it's got the player tag, it's probably pretty safe to assume there's a player character component on this game object that entered our trigger. So we'll make a variable of the type player character, and we'll call getComponent on this thing that touched our trigger and search that game object for something of the type player character and store that inside of this player variable. And then once we have a variable for the player character, we can call functions on that object. So we will call the set current checkpoint function. And if we go back to player character, we can remember that set current checkpoint, it just takes in an object of the type checkpoint and stores that object in the current checkpoint variable of the player character right here. So we are passing in this particular checkpoint that the player bumped into the set current checkpoint function, which will store it in the player's current checkpoint variable here. So now that I know about what my current checkpoint is, I need to add some functionality to the player so that it can actually respawn from the current checkpoint instead of just reloading the whole level when we touch the hazard. So inside of my player character script, I'm going to add another function that is for respawning. Respawning is something the player can do, so I will define that function in my player character script. So I'll say private void respawn, and inside of this function we have to decide what kind of logic we need to do for when the player needs to respawn. And we could make this pretty fancy if we wanted to. We could play a death animation, we could fade the screen to black, then move the player to the respawn point, which would be the current checkpoint, fade back in, and then have the player be playing again. But at least for now, we're just going to settle with simply moving the player back to the last checkpoint. And that's all we're going to do to begin with, and we can add more and more to this as we need to. But that's the basic functionality that'll get us what we need for just testing our game. So to change something's position, if you look at your player character, we want to change its position here. And so position is a property of the transform component. So transform is actually the only component that every single game object is guaranteed to have. So as a result, we can skip the step where we would normally have to make a variable and then initialize it with get component because we know everything has a transform. So we can skip get component only when it comes to transforms. And because of that, there's a built-in reference to the transform of any game object that you're dealing with, just called transform. So if I type transform here, that's a reference to the transform on the game object that this particular script is on. So since the player character script is on the player character game object, it will be a reference to this transform. Alright, so I'm going to say transform.position equals, I'm just going to move it to the position of the current checkpoint. So that would just be current checkpoint dot transform dot position. And so if we save it, and I'll have to make sure and save all of my scripts here because I have changes on checkpoint also. We should in theory be able to run the game, touch a checkpoint, and then die. Oh, well actually we're forgetting one thing. We still have to call respawn. So when do we want to call respawn? Well, that's when the player touches the hazard, right? So basically instead of doing this stuff that we were doing, we're going like where we were reloading the scene. I'll just comment this out for now. We actually want to respawn the player. So what I'll do, this is going to have to work very similarly to how the checkpoint is working. Meaning you can go ahead and copy this line right here inside of checkpoint. So copying line 12 and checkpoint here. And I'm going to go into my hazard script. and I'm going to paste it in. So we need to get a reference to the player because the respawn function is on the player script. So now that I have a reference to the player, I can go in and call the respawn function, except remember I have to make this one public also because I need to access it from outside of this player character script. So change your respawn function to be public, and then in your hazard script, right after we've gotten a reference to the player that's touched the hazard, so on the next line I'm going to say player.respawn. And I'm going to leave this commented out because this code is going to come in handy in a second. So don't delete this just yet, but make sure it's commented out because we don't want to reload the game whenever the player touches the hazard anymore. We want to respawn when the player touches the hazard. Okay, so I need to save my player character script also. And now I think if I go into Unity and run my game, so long as I make sure I touch my checkpoint first, I can touch the spike and respawn at the checkpoint. And this particular level design is kind of bad because the ice is so slippery that I can have enough velocity to keep hitting the spike over and over and over even after I respawn. So anyway, that's an issue with my level design, but the basic functionality of respawning from the checkpoint is working. So I could fix that by either not making this ice, or maybe moving the checkpoint, or maybe moving the spike. I'm going to move the checkpoint so that the player really has a hard time of getting past it without hitting it. So there we go. Actually, I'm noticing what we might want to do, since when I'm respawning, I'm actually keeping my velocity. That's why it's kind of working like Portal. And that's a fun mechanic, but it's not what should happen for a checkpoint. So we should go back to our checkpoint code here, or actually our respawn code. And when we're respawning, we should set the player's velocity to 0 so that the player isn't moving as soon as they respawn. We want them, right now their velocity is carrying over after they respawn, and we don't want that. So we're going to say we have a reference to our rigid body, I believe. Yeah. It's called RB2D. So remember, rigid body is all of the physics information about our player character, and so that will cover velocity. So inside of our respawn function, before we move the player's position, I'm going to say rb2d.velocity equals. And so velocity is a vector 3. And you might normally need to make, well actually since it's a 2D game, it's only a vector 2. So what you could do is set it to some new velocity, but there's actually a built-in one called vector2.0, which is just exactly what I need here. So we will set our velocity to 0 and then change our position. So that's what respawn will do. Let's save that and go back to the game and test that out. And in theory, I should just respawn at this checkpoint and then kind of just fall with gravity right back to the floor without continuing my forward momentum. Yeah, that's a lot better. Yeah. Cool. All right, so that works better. Now, there is a bug left over that we need to address. So let's move the checkpoint again somewhere where I could skip it. I'll put it here. This is bad level design, right? You would want to have your checkpoint before the thing that could possibly kill you. But just to show you what happens if I call respawn by dying before I hit a checkpoint? And you can see we're getting this null reference exception. Alright, well, what does that mean? I'm going to stop the game. If I double click this error, anytime you see a red stop sign like this with the exclamation point, that's an error. And it's not a good idea to ignore errors. So this one, sometimes you'll get a compile error, which is what you get if I just type something that is not code or wrong into my script and save it. You'll see that I have, this is a compile error, and I can't even run the game when I have a compile error, right? So that's one type of error, but if I get rid of this and save so my game compiles again, sometimes you'll be able to run your game, but while the game's running, you'll get errors, which is what's happening with this null reference exception. So this is what's called a runtime error. And a lot of times people will either not notice the runtime errors or ignore them, and then their game won't behave the way they expect, and they don't understand what's wrong. And essentially, the way I like to explain it is once you see a runtime error, that's sort of like a deal breaker. You need to stop and fix it. Otherwise, you can't expect anything else to work correctly. So anytime you see a runtime error, even though your game is still working, it's a very good practice to stop what you're doing and figure out why you got that runtime error. So what I'll do is I stop the game and I'm going to double click it, and it should, if we're lucky, take us to somewhere in our code. That's actually, this would be the last line we hit when we encountered the error. And so if I look at this, the error is saying that an object reference is not set to an instance of an object. And so that's what a null reference exception is. And basically that means that I'm trying to do something to an object that is null. And in this case, it takes a little bit of experience to be able to quickly identify what's going wrong. But I know I told you that everything has a transform for free, so that's not the problem. I know there actually is a transform on this player character. So that's not the thing that's null. Something that's null just means it doesn't exist or it's empty. I know every transform has a position, so that's not the problem. And the next choice of what could be null is current checkpoint. Well, does current checkpoint have a value when I start the game? I can look at it and see that when I declare it, I'm not initializing it. It's just left empty. So this starts off null, and it doesn't get initialized until something calls our set current checkpoint function, which is, this is where we're actually assigning it a value. So until this gets called, we will get a null reference exception whenever we try to respawn. Whenever we try to use current checkpoint before we've actually assigned it to anything, that's when we're getting that error. So to fix that, we either need to assign a default value to the current checkpoint, or we just need to make sure we never call this line of code and never try to use current checkpoint until it has a value. And so in this particular case, I think that latter strategy makes more sense. So what I'll do is I'm going to say, actually, I'll do it right at the top of respawn. We'll say if current checkpoint equals null. So if this current checkpoint is null, we don't want to use it, because trying to use it when it's null will give us that runtime error, the null reference exception. So if it's null, let's go ahead and reload the level like we were doing originally. This is what would happen if the player has never hit a checkpoint yet, but they die. That's when we're just going to go ahead and restart the whole level. And that's why I had you, if you go back to your hazard script, hopefully you didn't delete this line of code, because this was our code that restarted the whole level. So I'm going to hit Control X to copy that code. I'll delete the little comment artifacts there and save. Let's go back to player character, and I'm going to paste that line back in. Now, a couple of things to note. First of all, Scene Manager is underlined in red, and you might remember that's because Scene Manager needs a using statement. So I'm going to go ahead and hit Control period, that's just in Windows at least for Visual Studio, that's the hotkey to get the quick actions or the quick fixes. And the quick fix here is to add the using statement for Unity Engine.scene management. So I'll click this one, and that, if we were to go up to the top of my script, you'll see it added that using statement. So now this particular script has access to all of the functions that belong to the scene manager class here. And so now it recognizes a scene manager.load scene, and this line of code will work. I also want to point out that there's no, so far in my code, what I've been doing is, and when I have an if statement, I've been using a open curly bracket and a close curly bracket, and then putting the code that should be governed by the if statement inside of the curly brackets. And that's a good practice, but if you only have one line of code that should be governed by that if statement, it's also syntactically okay to not have the curly brackets. So this syntax is just sort of like an abbreviated version of the full if statement syntax, and it only works if you only need one line of code to be governed by this if statement. I'm not sure what I just hit. I must have hit a button or clicked something, but anyway. So yeah, since I only need one line of code to be governed by this if statement's condition, I can leave out the curly brackets. And you want to make sure you're indenting just so that it's visually clear that this line only happens based on this condition. Alright, so if there's no current checkpoint, we want to reload the game. Otherwise, we want to do all that stuff. So typically that means we'd want to put this stuff inside of an else statement here, right? And in this case, there's more than one line that should be governed by this else condition. So we will have to add the curly brackets and move these lines inside of the else statement here. Technically, I don't think we needed to do this, because if we reload the scene, it will just sort of like totally start over, so this code would never be reached anyhow. But I still think it's worth putting it inside of the else, just because this is more honest with what we're trying to accomplish. We want to do, if the thing's null, we want to do this. Otherwise, we want to do this. And so I might as well express that intent in my code. Otherwise, it may be unclear. Okay, so I'll save this. Make sure all your stuff is saved. Go back to Unity and make sure that clear on play is clicked in. It's kind of tough to tell in Unity the difference between when these buttons are pressed and unpressed. So it's kind of lighter color if it's selected. Make sure clear on play is always selected. Otherwise, when you run your game, these runtime errors won't go away. And so it may not, you may have a tough time understanding that you actually fixed the error or not, because the error will still be left in the console. So we definitely want to clear on play, so each time we run the game it's a clean slate and we can see any new errors. And now I'm going to hit the spike without touching a checkpoint first, and now I'm no longer getting the error. And so if I were to, I think I can jump over the spike and touch the checkpoint. And now if I hit the spike, I respawn at the checkpoint. So both cases are covered now. I can respawn at the checkpoint if I've hit a checkpoint. And if I haven't hit a checkpoint, I just respawn at the beginning of the level. So that's working well. Alright, so let's go ahead and stop this video here. And in the next video, what I want to fix is we're not giving the player very much feedback when they touch this checkpoint. We're printing stuff to the log, but the log is not a thing that our player's ever going to see. So we need to do better at indicating to the player, yes, you actually did a thing when they touch the checkpoint. And we can work on that next.